For example, the default administrative distance for static routes is 1. If we modify, I want the above route appear in the routing table. The following route does not appear in the routing table. Then if I modify the administrative distance, how much should I change it to? You have to remember, smaller is better. So if you want to have multiple static routes, let a certain link or a certain route. Choose it first. Then we can choose increase the administrative distance of other routes. We can accomplish such a situation. So let's do it. I am now viewing the configuration just now on R1. I teach you a command called show running config. I'll check it out. Now included in the configuration just made. What are the configurations about routing? IP route. Okay. Here are 2 routes. So since we want this preference, we just hope this one goes down. So, I want to be in configuration mode. Cancel this route for it. No. And copy it over. Now this configuration has been cancelled. After cancelling, we reconfigure. That is, reconfigure the route just now. But after the configuration is complete, we can put a question mark in the back. Enter a distance metric in this. Is the administrative distance of this route. We can be here. Modify the administrative distance of this route. 1 is a default value. I want it to be greater than 1. Because it is greater than 1 it is not good. The smaller the management distance, the better. So I'm assuming to change it to 2. What is written in the PPT is 100. But it doesn't matter. Greater than 1 on the line. I changed it to 2. Let's still check the configuration just now. Now, when I'm doing routing check, we'll find there is no number behind the first line I configured. Because it defaults to 1. Default is not displayed. The management distance in the second one is changed to 2. Everyone can guess. Now for the 2 configurations. Its administrative distance is different. Then according to the principle of adding table we thought before, when all destination networks are the same, we'll trigger the comparison. Now they are both 8.8.8.8. 32-bit mask are the same. The destination network and mask are the same. We'll trigger the comparison. Then we first compare the administrative distance. So when we compare now, smaller is better. So, 1 is 1. 1 is 2. Obviously the first one is better. If the first one is better now, the second item will not be added. Let's look at the routing table now. Its next hop is only 10.1.1.2. It will not be added to the table. So for 2 routes, now its administrative distance is not the same. The principle of adding tables. We'll select an optimal table addition. So there will be no other route. But that's just saying. Now only 1 route appears in the routing table. Then according to what we just said, this situation is drawn in this picture. How can this line complete a switch? That is our scene. The reason why 1 line is the main line. 1 line as backup line. It is hoped that the daily traffic will take the main route. If the main line fails, take the backup line. So how can we let the main line fail? Very simple. I just need to enter the interface. Just shut down the interface for it. Let's say I'm on the device on the left. Our interface to the main line. Then give it shutdown. Then once I shut down now, we can observe the phenomenon. Excuse me. Is the route still there? Let's check. The route just now is gone. Now the next hop that appears in the routing table becomes 20.1.1.2. That is becomes the address of this interface. Now the traffic goes the following route. Why once this interface is gone, the corresponding route disappears? For routing, if the physical state of a port is up, then the corresponding direct route exists. Remember the direct route we talked about earlier? That is, this interface is configured with an IP and no shutdown. The peer also has an interface. It means that the physical state and the protocol state are both up now. A direct route will be generated. This is what we said before. The physical state of the port is up. Then the direct route exists now. Then if the physical state is down, actually, this interface is not working, then the direct route disappears. So for the current environment, because the ports are down, there is no such direct route. Its next hop is of course unreachable. So this route is correspondingly gone. Because now the next hop is the direct connection. Then this interface is actually down. If there is such a route in the routing table. Future visits. I can't forward it. Because the interface is gone. It doesn't make sense. Let's test it now. For example, I ping 8.8.8.8. Still works. Because the route must go the following route. Then if I restore this interface now, will it retable? Okay. It will be relisted. Because if the route comes back, to retrigger the comparison again, we can verify. For example, I entered the 00 interface. I turn on this interface, no shutdown. I hope it pops up some log messages later. Okay. Finished playing. Let's check now. IP route. Okay. Now in the routing table, the next hop becomes 10.1.1.2 again. That is, it's on the line again. Route restored. So we will now find if when this interface is enabled, the next hop in the routing table becomes the main line. If this link fails, then the next hop in the routing table becomes a backup line. So, given that we have defined the administrative distance, in fact, as long as the main line does not fail, it is forwarded normally on a daily basis. If it fails, go the following line. If it recovers, go the above route again. So this route about 8.8.8.8 in the routing table is always changing. That is, according to the current real forwarding situation of the main line. If it creates problems, it just sinks. If it's okay, it resurfaces. So we call such a route a floating route. Usually, it's actually called route backup. It is a backup technology. I now have an extended question. For example, now this interface is all fine. But if you get into this device, I put it on the interface, and if it is down, do you think I can ping now? We are now on R2. Enter the interface of R2. 00 interface. Shut down. I now down this interface. If I look up the table on R1, how much is the next hop? I repeat. If R1 goes to 8.8.8.8, the next hop is this interface. So we just verified. If I put the router on the left, this interface is down. The routing will switch to the following line. If this interface recovers, just go the above route again. That is, regardless